All right, boys and girls, we're going to continue with the science end of year test review. Um, Today we're going to look at rocks and minerals, and we're going to start off with minerals first. Let's talk about what are the 5 characteristics a substance must have to be a mineral. Again, it must have all 5 of these characteristics in order to be a mineral. Okay, it has to be naturally occurring. That means all minerals are substances that are formed by natural processes. Has to be solid, cannot be liquid. Minerals always has to be a solid with a definite volume and shape. Crystal structures. The, the particles of a mineral line up in a pattern that repeat over and over again. Formed by inorganic processes. All minerals must be able to form by inorganic processes. That is, every mineral must be able to form from materials that were not a part of living things. Definite chemical composition. A mineral has a definite chemical composition. That means a mineral always contains certain elements in definite proportions. You have some minerals that are also elements found on the periodic table, such as gold, silver, copper. All those examples are minerals, and they are also examples of elements found on the periodic table. So again, in order for a mineral or substance to be a mineral, it must be naturally occurring, solid, have a crystal structure, formed by inorganic processes with a definite chemical composition. How are minerals identified? Lots of different properties here used to identify minerals. So we look at color, streak, luster, you have metallic, non-metallic, hardness, density, crystal structure, breakage. With breakage you have cleavage and fracture, and then special properties such as does it refract light? In other words, does it bend light? Does it glow under UV light? Does it have a reaction to acid like calcite does? Is it magnetic like magnetite is? Does it smell? Sulfur smells like rotten eggs. Does it taste bad? Like, well, halite. Halite is salt, so it tastes salty. Okay? So all these are properties that are used to identify minerals. Okay? Now, color, you would never really use color because color can be, or minerals can be all kinds of different colors. Okay? So color is not a very reliable property. Streak, however, is. Minerals have a certain colored streak no matter what color they are. Okay, so no matter what, minerals will always have a certain colored streak. Okay, when we look at cleavage and fracture, and well, let's start with hardness. We'll talk about the Mohs Hardness Scale in just a second. Density. Density is a good one, a good property to use because minerals have a specific density to them. Again, if you don't remember density is equal to mass divided by volume. And that's how you calculate density. Breakage, you have cleavage and fracture when a mineral splits apart to form flat surfaces. And when a mineral breaks apart in an irregular way, that is fracture. So let's look at these a little bit closer. Here is an example of mineral streak. You take a ceramic plate, you rub the mineral on the ceramic plate, and you look at what color is its streak. That will help you identify the mineral. Metallic versus non-metallic. So this is luster. Okay. A lot of people get these confused. They think if it's shiny, it has metallic luster. That is not true. Look at this mineral here. It is shiny, but it has non-metallic luster. So what is the difference? Well, these minerals over here, such as pyrite, they look like pieces of metal. That's what metallic means. So all of these minerals over here look like pieces of metal. This does not look like a piece of metal. So again, don't get that confused. Just because something is shiny, it does not mean it has metallic luster. Fracture, okay, when it breaks apart in an irregular way. Look at this. These are all examples of minerals breaking apart in an irregular way. Cleavage, they break along flat surfaces. Okay, the best example is mica. Look at this, flat surfaces. Here's another example. Galena, another example. Okay, if they break apart along flat surfaces, they have cleavage. If they don't, they have fracture. All right, Mohs Hardness Scale. Mohs Hardness Scale is a scale used to rank the hardness of minerals. It assigns a mineral's hardness a ranking from 1 to 10. Hardness can be determined by a scratch test. A mineral can scratch any mineral softer than itself, but can be scratched by any mineral that is harder. The softest mineral on Earth is talc. It flakes when scratched by a fingernail. Diamond is the hardest. Okay, so here's the Mohs Hardness Scale. All right, diamond, the hardest mineral on Earth, can scratch all these minerals below it. Okay, it can also scratch itself. Corundum, the only mineral that can scratch corundum is diamond. Topaz, the only minerals that can scratch topaz is corundum and diamond. It can scratch everything that is below it. Okay, so when you're doing the Mohs Hardness test, you always start out with the fingernail. If you can scratch it, you know that that mineral has a hardness between 1 and 2.5. If a copper penny can scratch it, then you know its hardness is between 3 and 3.5. If a knife can scratch it, or a glass plate, you know it has a hardness between 4 and 5.5. Okay, so hopefully you understand how the Mohs Hardness Scale works and how you use it to identify minerals. Okay, why do you need to test several properties of a mineral to identify it? You need to test several minerals of a property to identify a mineral because some minerals might have the same property or properties that are very close. For example, two minerals may have the same color and streak but have different hardness. So you have to test multiple properties. You can't just say, oh, well, here's a streak test that has a black streak. Yeah, it's got to be this. You got to look at hardness. What is its hardness? What is its streak color? What is its luster? Is it metallic, non-metallic? Identified minerals sitting in front of you, what would be the quickest way to identify these minerals? First, you find out if the unidentified mineral has a special property that you could test. For example, quartz and calcite look very familiar. However, only calcite reacts to acid. So if you've got two minerals in front of you, you know one is quartz, one is calcite, then you would look at, you get hydrochloric acid, and if one bubbles and fizzes, you know you have calcite. You don't even have to test any of the other minerals. Properties such as streak, luster, hardness, because you identified it with that special property. Magnetite. Magnetite is attracted to magnets. So if a magnet sticks to a mineral, you know you have magnetite. So special properties is the quickest and the best way to quickly identify minerals, unidentified minerals. Okay? So let's get into rocks now. How do geologists classify rocks? To study a rock sample, geologists observe the rock's mineral composition, color, and texture. If a mineral has if a rock is multicolored, it is a sign that it has multiple minerals in it. That's what gives a rock its multiple colors, is all the minerals that is found in it have different colors. What are rock-forming minerals? The 20 or so minerals that make up most of the rocks on Earth's crust. What are the type of grains found in rocks? So there are three types. Fine grain rocks have grains that are so small that you can only be seen with a microscope. Coarse grain rocks have grains that are large and easy to see, and then no visible grain. Okay. What are the three major groups or types of rocks found on Earth? So we're going to look at igneous, sedimentary, and metamorphic. So let's look at igneous first. Igneous rocks form from the cooling of magma or lava. The magma hardens underground to form rock. Lava erupts, cools, and hardens to form rock on the Earth's surface. The two types of igneous rock are intrusive, formed from magma inside the Earth, coarse grain. It cools very, 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 very slowly. That's why it's coarse grain. Large, easy to see, visible crystals, because it cooled so slowly allowed those crystals to grow. Extrusive, formed on the Earth's surface. Fine grain, or sometimes even no visible grain. Obsidian is an example of that. No visible grain. Looks very glassy, okay? Again, difference between magma and lava. Magma is hot molten rock beneath the Earth's surface. Lava is hot molten rock on the Earth's surface. Here's an example, intrusive versus extrusive. Large, coarse grain, easy to see, visible crystals, because it formed very slowly inside the Earth. That's what intrusive means. Extrusive, cooled very, very, very quickly on the surface of the Earth. Very fine grain, and sometimes no visible grain at all. So there are some examples. Diorite, granite, pegmatite, gabbro, all intrusive. Basalt, andesite, rhyolite, and scoria, all examples of extrusive. And some of these, and most of these, you actually saw in the labs that we did when we were looking at rocks and minerals. So now let's look at sedimentary rock. Sedimentary rock forms when small particles of rock or the remains of plants and animals are pressed and cemented together. Sedimentary rocks form in layers that are buried below the surface. Sedimentary rocks are formed through weathering, erosion, deposition, compaction, sedimentation. Here are the three types of sedimentary rocks. Okay, clastic, formed when small rock particles are cemented, compacted, and glued together. Organic, containing once living things. And chemical, made through evaporation or chemical changes. So here's some examples of sedimentary rocks. Breccia, clastic. Okay, all those large pieces were compacted and cemented together. Chemical, you have rock salt there, formed from the evaporation of salt water. Organic, you have an example of coal there. The remains of dead and living organisms were compacted together over thousands upon thousands upon thousands, if not millions of years, to form coal. Metamorphic rocks form when the rock is changed by heat or pressure, or by chemical reaction. Most metamorphic rocks form deep underground. The two types of metamorphic rocks are foliated, means you have banding. You can see bands. Okay, metamorphic rocks that have their grains arranged in either parallel layer bands and are said to be foliated. Foliated describes the thin, flat layering in most metamorphic rocks. Examples is gneiss, once was granite, and slate, once was shale. Non-foliated, the mineral grains in these rocks are arranged randomly. Example would be marble and quartzite. So there is an example of foliated. You have that banding, okay? Non-foliated. So this is quartzite and this would be gneiss. Okay, we talked about sedimentary rocks. Oh, which of them have fossils in it? It'd be sedimentary because igneous rocks are made from magma or lava that would melt anything that could create a fossil. And metamorphic rocks also go through lots of heat and pressure. So if you find a rock with fossils in it, you know you have a sedimentary rock. Rock cycle describes a series of processes that occur on Earth's surface, in the crust and mantle that slowly change rock from one kind to another. In the rock cycle, any rock can become any other type of rock. Okay, so let's look at that. And all rocks are made of minerals. Where do rocks come from? Other rocks. Very important. Key. All rocks are made of minerals. Where do rocks come from? They come from other rocks. Here is the rock cycle, okay? So igneous rock can become sedimentary rock through weathering and erosion, turning into sediment, compacted and cemented together into sedimentary rock. A sedimentary rock can then become metamorphic rock through heat and pressure. That metamorphic rock can then erode back into sediments, be compacted and cemented together into sedimentary rock, or the sedimentary rock can weather and erode into sediments and then become sedimentary rock again. Okay, so there is no one set way through the rock cycle. It can go multiple different ways. Igneous rock through melting can become magma, cool, right back into igneous rock. Okay, so all right, that is a very quick version of rocks and minerals. Have a great rest of your day.